Okay, microphone check. It appears to be working now. Zero watching. Mic check. Okay, I think the microphone is fixed now. Yo, the 666 bud, did you get a notification for this live stream? Because I think sometimes if I start live streaming and then there's a problem and then I stop and I start again, it doesn't tell a notification the second time I start again. Sweet, great. I'm glad you guys got a notification. Good stuff. So, good evening from wherever you are in the world. This is another episode of We Repair Fucking God Knows What because it's blown up in the UK. And we were starting earlier, just before my live stream broke because the microphone broke and then my internet broke. We were looking at this JBL GTO 75.2. Now, it turns out that I've actually repaired this already. Just now. Actually, whilst the live stream was fixing itself, I just repaired this. And this was a really simple one. The only issue with this was that the gain knob and the switches were incredibly dirty and dusty inside. And therefore, they were creating some... Oh, what the fuck? And therefore, they were not allowing the audio signal to pass. And so there was no audio, so I just gave the whole thing a clean with some isopropyl alcohol, and now audio passes and it works. Giant says, thanks for your help earlier, good to see you, we'll be tuning in for a couple of hours. Awesome, man. Well, hopefully I have some good content for you. I'm just putting this JBL back together because I just fixed it. just whilst I was sorting out my microphone issues. Managed to very quickly sort this JBL, which is nice. The clamp designs of these ones are really strange, and they're kind of annoying and they're kind of old school. So if I show you from this angle how to do these clamps, they confused me at first. When I first saw this style of clamp, I was a bit like, what the fuck? So excuse my nose as well. I've not been very well recently. So. Well, basically, you have to take this part here. Now, this part has some sort of cardboard on the back that the FET goes on, or the transistor in this case, and you sort of slide that over there, slide that over, and then this part clamps onto it. And you have a little curve at the edge here, and the curve goes on down the bottom, matches up with this curve. You slide it on from the side in the slot. There's a slot at the side, like a rail that it slides along. What the fuck? Yeah, sorry, there's a rail that slides along the side here, and if I unscrew that a little bit more, it slides over the top, and you have to make sure that it's in the rail, sits on top like that, and then once it's sitting on top, you can screw it down and it puts pressure on the transistors and pushes them against the heatsink. Are you bringing your tools and stuff to ModNats? Yes, I am. I'm going to try and bring my whole amplifier repair kind of setup to ModNats somehow. I've got a powerful inverter now for the van, so I can bring my scope, my soldering iron, everything that I need to do amp repairs at ModNats. I'm going to try and stock up on some spare parts as well, so if anybody blows anything at ModNats, then I can maybe... And, you know, this isn't a guaranteed thing, it's like a maybe I can make a repair at ModNats. There's no guarantee that I'll be able to make a repair at ModNats. It depends what the issue is with the amplifier. the blows, but hopefully I can make a repair. Hello to Daniel Pond. Good evening, my friend. Hope you're well. Interesting evening coming up. Yeah, I hope so. Hopefully this is going to be an interesting evening coming up. So I've got a couple of options for you guys as to what I can repair this evening. I've got a Taramps HD 10K that I can do. Actually, I'll go and check what I've got in the list, and then you guys can decide what you want to see. The only one that I can remember off the top of my head is a Taramps HD 10K. Howdy from Missouri. Howdy from the UK, my friend. How's it going? It's a Sunday and I'm feeling fine. $10K all the way, says Rob C. So people want to see the Taramps 10K. This is a really generic issue with, oh wait, what the fuck? Oh yeah. The Taramps 10K has a really generic issue with the power supply. I'm going to have to swap the PIC chip. So that could be a cool one to see. I'm going to have to swap the PIC chip on the Taramps. So that could be some nice SMD soldering for you guys to see. It's been about a couple of weeks amplifier wise. You remember I told you I blew up a couple of strapped massive Drago 10Ks. Oh yes, I do remember you saying about that. How's that been going? Have you managed to sort any issues with that, or are they still not working? Who saw, oh, what the fuck? Yeah, so who saw the post by Tony, I think it's Amor? Tony Damore, or whatever his name is, the guy behind the SMD DD1. He made a Facebook post about my video. That's why I'm wondering how many of you guys saw that. The manufacturer replaced a pair of them for less than I could find anyone to repair them in the States. And guess what? Ah, go on, Daniel Pond, guess what? Oh no, hopefully they didn't blow again. Don't tell me that they blew again when you got the replacements. That would be massive headaches. I hope that that's not the case. Yeah, so Tony's post raised a good couple of points. That the small speaker picks up distortion sounds before you see clipping on the scope, and when you first hear the distortion sound coming from the speaker, the first instance of distorted buzzing that you hear isn't the amplifier clipping as such. It is just some noise that all Class D amplifiers create when the output sine wave is starting to reach the rail voltages. That does count as THD, by all means, that counts as THD, but it's not clipping as such. However, if you listen carefully to the buzzing sounds that the speaker makes, you can distinctly hear when the sound changes from this Class D buzz to actual clip. There's a difference in how the buzz sounds. The buzz is much more intense and it has a different tone to it when the amplifier actually reaches the clipping point. So you can still use that small speaker method as a clipping detector, provided you know what you're listening for, and you need to know to listen for the second buzz that is a slightly different tone and a little bit more intense. Don't you fear burning the phosphorus on your oscilloscope screen? Huh? Well, by having it on all the time? Not really. I mean, I've been using the scope like this for over a year now, with it being on a lot of the time, pretty much for hours and hours on end, and it's been spot on, been perfect. Good evening, Carlos. ¿Cómo va, amigo? Vi o video de peruca la hora. I'm not good enough at Spanish to understand what that means. I need to Google Translate that. Talking of inverter, I have an inverter I bought broken, repaired it. I have to replace 40 IRF3205s and the driver ICs. It's a pure sine wave inverter that works at 24 volt out, 24 volt. Okay, outputs 2.5 kilowatt. Yeah, it's basically an amplifier. It's basically an amplifier that has a fixed frequency at 50 or 60 hertz. It's pretty cool. I don't know if you guys saw on my last live stream, so whoever was watching my previous live stream, which was, we were looking at the Banda, and whether it had fake FETs, I actually used the Banda 10K to run some mains equipment on the amplifier. And that was pretty cool. That was a good fun little live stream, that. Blonde hair video blowing in the air. I'm glad people like that. It's a good fun video, and it's a really fun van. I fucking love that thing. I'm falling in love with that van. Wait, hang on, what language is Carlos speaking? Is it pure Spanish? I thought hair was pello. Or pello. Pello? Pello? I thought that was hair. Oh, but wig. Ah, yes, blonde wig. So it's not hair, is it? It's wig. So the word is wig, not hair. Okay. That makes sense now. Ah, no. Yes, another one blew, unfortunately, upon only having a subwoofer. The power cable was connected. No input or output. Just a remote turn on and power. Suspect it was roughly handled during shipping. Yes, possibly. Or perhaps was it a refurbished unit that wasn't repaired properly from whoever refurbished it at the at headquarters, maybe? Ah, Carlos says my language is different. It's Portuguese. Ah, that makes sense. Yeah, there are some differences there. And so because I'm not that great at Spanish, I'm going to be even worse at recognizing some Portuguese words. That's cool though. Okay, so are we going to look at the Taramps HD 10000 next then, yeah? Is that what you guys would like to see? I wonder how many Spanish subs you got from the Spanish video. I don't know. To be fair, the Spanish video isn't as popular as I thought it might be. I thought maybe that video would branch out into a lot of Spanish-speaking countries and it would get like a few thousand views, but it's not actually doing that well. I think it's only just hovering around 1,000 views at the moment. Might not even be there yet, but that's fine. It was an experiment and it was something that I always wanted to do. This blowout was not as spectacular, and having the speaker leads shorted, but as soon as the internal relay clicked in, it let the magic smoke out. Yeah, that sucks. Okay, right, so that's this JBL fixed. So this JBL actually didn't have anything wrong with it in the sense of a circuit. It was just the gain knobs and the switches on this side were all really dirty inside the actual switch. So I took some isopropyl alcohol, sprayed it all up in these knobs, and like flicked the switches backwards and forwards like 100 times, and twiddle the knobs back and forward like 100 times to let all the alcohol clean off the contacts in there, and then it made clean audio again. So yeah, nice easy fix, didn't have to replace anything in this one. So I'm just going to go ahead and yeah, let's get the Taramps 10K and start work on that. Okay. Hello, Dan. Yo. Chevys. Your Spanish is 100% clear for us. Ha, Carlos, that's only because I use Google Translate. If I want to make an outtakes video, actually, like when I was making the Spanish video, because I learned Spanish in school, right? And in school, they don't teach you how to say Spanish words for amplifier repair. They teach you how to say, where is the police? Where is the hotel? How much is this hat? And shit like that. They don't teach you how to say, we need to check the square waves on this MOSFET. They don't teach you that in school. So I had to use Google Translate to work out what a lot of the words were. And there was many outtakes from that video. It's very funny. Of me, I was like here doing the amp repair like this. And I was looking at the screen, like I was like, blah 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 blah, and I'd say like something wrong, and no, what the fuck does that say? And I'd try and pronounce it again, and I say, okay, take 2, and let's try again, and then say it wrong again, and take 3. Yeah, they're very funny outtakes. Okay, so here on the bench we have a Taramps HD 10000. Now, for some reason, I haven't figured out what the bloody hell problem is with these things. They always blow their power supply for apparently no reason. You get a brand new amplifier and you run it properly on good power, you run it on good voltage, and eventually, no matter what you do, it will blow the power supply. And once it's blown the power supply once, you keep repairing it. You replace all the FETs, all the drive ICs, all the gate resistors, everything pretty much. You replace it all, and it still blows the power supply section. Like, after a few days, a few weeks, a couple of hours. I don't understand what the fuck is the problem with these things. So, this one has, you guessed it, blown the power supply. And I repaired this once already before, and it blew the power supply again. So, I've got it back in the workshop now. Now, this guy wants this repaired for Modified Nationals, car show in the UK, coming up this weekend. So, it's obviously got to last till then. It's got to last for the show. Now, when it blew the second time, it actually blew the PIC. If I take my zoom-in camera here, my normal zoom-in camera doesn't work at the moment, so I'm having to use my handheld camera. So if we take a look on the board here, you can see that there is a teeny tiny little chip here. You see this? This is the programmable IC. This is the PIC. This is the amplifier's brain. This is the thing that is telling the amplifier, well, it's controlling the power supply section, it's controlling the pulse width for the power supply, it's controlling the output section, it's controlling the protection circuit. Basically, this is the firmware that controls the amplifier. And this time, this chip is blown. It doesn't seem to be working. It seems to have died because when you plug the power into the amplifier and you hit the remote, usually you should get the LEDs here. They start to light up and they go blue, orange, red, and then like they come on. And then you get square waves over at the driver pad. So you can see here these, when this focuses, this is the empty pad for the drive IC for the power supply. And usually you get some pulses on these pins when you hit the remote, and the PIC is sending the pulses to these pins. But it's not doing that. This amplifier, when you apply the remote, is just dead. It's not doing anything. The only thing this amplifier does when you put the remote on is the little voltmeter screen here lights up and comes on with voltage. That's the only thing that this does. So I have diagnosed the issue down to the PIC being dead. So what I'm going to do is, on this amplifier, I'm going to change the PIC. I've got a spare HD10000 I can steal the PIC chip from temporarily, and then we'll get a new one from Taramps for the other one. And then I'm going to replace all 4 drive IC chips, load up with some new IRFB 3077s, and then we're going to do some endurance tests and see if it lasts or not. Headshotter has a good suggestion. Maybe the pulse duty cycle goes 100% for a long time. Basically, in these amplifiers, 100% duty cycle would just be DC. So basically, full power is 50% duty cycle in these power supplies, because it's 50% on, 50% off. That's the full power. And to be honest, the amplifiers, they run at 50% duty cycle or maximum power at all times anyway, unless you have a regulated power supply, which not many amplifiers do. So running at full power supply wouldn't be causing the issue. I think that possibly the PIC is glitching. I wonder whether when the PIC gets to a certain temperature, it glitches and it throws the power supply off and blows it. So, because basically the power supply in these Taramps is not really, it's no different to the power supplies that you see in the Banda. The Banda Viking amplifiers use the same basic power supply. It's the 4427 chips driving IRFB 3077s or 1404s. The circuitry is pretty much the same. The only difference in the Banda is the PIC, the chip that's passing the pulses to the driver ICs, the 4427s. That's the only thing that's different. And the Bandas, they never ever blow their power supply. So if you've got 2 power supply circuits that are near on identical in design, one of them's blowing all the time and one of them isn't, then to me that's an issue with what is driving the power supply, in this case being the PIC. Andy, this says it. So you have to excuse. I keep having to sniff all the time because I'm still pretty unwell. Yes, I'm on the back end of a cold at the minute, so apologies for that. Andy says, "Is this the brand where customers were drilling holes in the caps at customs?" No, that was actually Banda. Yeah, the Banda amplifiers were being absolutely mutilated by customers drilling holes in the caps and also in the heatsink. Yeah, allergies. No, I think I've just had a flu. I do get hay fever, but I think I just had the flu recently. I seen it on Budget Boomers' Facebook page. Yeah, that would have been me. Yeah, Andy Turner. Yeah, man. If you're on Budget Boomers, I'm on there all day long. You probably see a lot of my posts on there. I'm just going to go and get the other Taramps to nick the PIC from. So here we go, this is the other Taramps HD10K, and this one I have had back in the workshop for a power supply repair. I think this must be the 5th time. It's either the 5th or 6th time now that I've had this one back in the workshop for a power supply repair. I repair it, I do an endurance test for over an hour, and it's fine, and the customer uses it in his car for anything from a few days to a few weeks, and it just blows the power supply again. And I can't for the life of me figure out why. But we're going to steal the PIC chip from this one. I'm going to lower the temperature on my on my heat gun a little bit, because these PIC chips can be quite sensitive to heat. I don't want to cook her up. I just want to remove her from the board nice and safe. So I'm going to apply a little bit of solder flux here. Now annoyingly, my zoom in camera is not working today, so I guess I could try to actually put the handheld camera here in the board so you guys can see what I'm doing at this funky angle. That might look quite cool actually. Let me try that. So if I put that like, wait a sec. Oh yeah, that looks pretty cool. Yeah, we'll go with that. Did you get the parts for the JL? No, the parts for the JL haven't actually arrived yet. As soon as the parts for the JL arrive, I'll be finishing that off, but they haven't actually arrived yet. Need my slightly wider tweezers. I'm trying not to knock the camera off. let me bend this bit of metal out of the way. Hey bro, got a TL494 chip giving a square wave on pin 9 and 10, but not on the gate resistor. Then you need to check what is in between pin 9 and 10 and the gate resistor. There might be a buffer transistor there. Well, there'll definitely be a buffer driver transistor. So the pin 9 and 10 doesn't drive the gates directly. It will drive it through a transistor of some sort, some sort of drive transistor. Ow! This is really hot. So if you're not getting it, if you're getting it on the 9 and 10, but you're not getting it on the on the gate, then it's the drive transistor that's faulty. So you need to look at that. It's taking longer than planned because the camera is kind of in the way of where I'm doing my tweezers. Okay, so it's coming up one side, almost there. There we go, finally. So I've got to remember that that one's the good one. And now I just need to put that down and go to the other one, the other amplifier, and do the same thing there. I wonder if I can get the camera angle in a similar good position, but so that I can also work on it properly. I need to get like a little camera stand for this. This would be better than the zoom in cam. I just need to get a little stand for it or something. Oh wait, there we go. That'll do. Is this your job now, or do you still have a full-time job? No, Andy, this is my full-time job and has been for over a year. Over 2 years I've not worked for anybody. I've just worked for myself, doing audio distribution, amp repairs, car audio setup, that sort of thing. Henrik, yes you can, my friend. For sure. Feel free to send me a picture of your amp and I'll let you know whether I think it's any good or not. You should buy a better camera. Yeah, the cameras are actually good quality. They're good enough quality for streaming, but I just need a little stand for it. I have an amp that needs repair. How do I get in touch with you? Says G-Man. G-Man, whereabouts are you based? Are you in the UK or are you based elsewhere in the world? Let me know, because that changes how you get in touch and how this works. Henrik just emailed me a picture. Okay, well I can't check that until after the live stream, but I will check it once I finish tonight and let you know. Post the video on the US 400. I won't bug you about it. No, I can't. I'm done with that now. That's gone. I'm not bothering to repair that one. Sorry, dude. I'm not fixing the US amps. I'm not doing that. It's gone. Sorry. Your van looks really nice. Thank you, dude. It's I'm kind of falling in love with the van actually. It's fucking really nice. Have you ever worked on a massive audio amp? No, we don't get massive audio in the UK really, so no, I've not worked on one of those, sorry. Okay, that should have done the trick. And to make sure that that's soldered on all pins, we can take a fine screwdriver or something. To be fair, my tweezers will probably work. Oh wait. Take a fine screwdriver like this. And we just want to go along each of the pins here, and if any of them bend away from the board, then we know they're not soldered properly. Yeah, I think we're good. I think they all soldered good. Okay, cool. So now I've replaced the PIC in this. The PIC from the amplifier that I stole it from, it worked in that amplifier, so I should technically just be able to plug these wires in here to this amp, and it should start to come on, and it should give me the drive waves that I need. Which flux do you use? I use this. Okay, so fingers crossed that PIC replacement was good. If not, we'll know about it pretty soon. Turn the power supply up. Let's get about 10 volts going on there. 9 point something is fine, 9.8 is fine. Get my probe. And now, what we want to see is on the scope, we want to see some pulses where the pads are for this. So, if I have a look at the pads on here, should see. I haven't applied the remote yet. I'm just working out where the pulses are going to be. So I think the pulses are going to be here. So if I turn my scope down, I should hopefully see pulses here, and also we should see the blue LEDs come on over here. Okay, so the LEDs work. And it's saying it's in protection, which it probably will do because it's not detected anything working. So let's see. We should have some pulses on these. There we go. That's what I wanted to see. Okay, so you can see the duty cycle changes. So we have good pulse there. Good pulse there. That's good. Now let's check this pads. Yep. 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 And the last one over here. Yep. Okay, sweet. So the PIC was the issue in this other amplifier. So changing the PIC, this little chip that can go in the sandcastle bucket. Cool. So now we have good pulses on each of the drive pads. So what I need to do now is take some new driver ICs for this amplifier, which look like this. Have you ever worked on Sound Digital amplifiers? No, because Sound Digital will not release any information about what chips or MOSFETs they are using in their amplifiers. I could probably sit down and work it out, but it would take me many hours, and I don't have the time for that. Yeah, I need like a little mount for this. What can I put it on for the time being? Maybe I could put it on my multimeter? Kind of want to go like... What one am I going to do first? Let's do this one first. The multimeter is not the ideal thing to put it on. I almost kind of want like some kind of gloopy stuff to put it on. Some kind of, maybe some kind of blue tack or something. Yeah, I thought some blue tack. That might work. Let's try some of this. Yeah, that kind of works, but it is kind of moving, so it's probably going to fall off, but it kind of works. Do you know anything about Ice Power products? I've never heard of Ice Power. Sorry. It's not a brand that we have in the UK, but it's probably the same type of shit that you have everywhere else in the world, so I could probably help you with it anyway. It's probably the same board designs as everything else. I'm just going to do the ones on the other side as well, now you know what I'm doing. Do those power supplies have feedback to keep the rail voltages steady? No, the rail voltages will fluctuate based on the input voltage to the amplifier. So if the input voltage goes from 14 volts to 12 volts, then the rail voltage will sink. Have you worked on any B2 audio amps other than the Duo? If so, do they really use higher-end components in a lot of manufacturers? Yeah, I've worked on some other B2 amps, and yes, they do use some better MOSFETs and thicker traces and a few other bits and pieces. So they do actually use some pretty nice parts compared to other brands, yes. How does the mic sound compared to normal? Is it clipping? Because I noticed that it looks like it's a bit more in the red than it usually is. So if my voice is clipping at all, if my voice is clipping like at the top, then let me know, and I'll sort that out. Not clipping, loud and clear. Good. Good, good, good. What's your opinion on Ground Zero SQ amplifiers? I repaired a Ground Zero I repaired one of the uranium. I think it was a UA. So GZUA 2225 SQ. Yeah, pretty nice amplifier actually. Pretty nice amplifier. It's a MOSFET funnel class AB. Yeah, it has a really good sound to it. A bit of a weird biasing, but no, it works well. Does the job. Sounds clean. Does really high power for considering how clean it sounds. This next one is the bitch one. This next one is the one that is underneath the flipping transformer. I don't think I can get this camera here to focus on that, so I guess we're just going to have to look at it like this. Oh no, I had it in the perfect position, I just accidentally jogged it out of the way. It's so frustrating when that happens. Oh man, fuck's sakes. Right, let's do that again. So annoying when you have a chip in the perfect location and your hand just does a little wobble and it pushes it right off. So annoying. Right, there. That should do it. Hopefully that last pin that's right at the back connected. Hopefully. I'm just going to blast it with some heat a bit more just to make for sure. Okay, I think that's soldered. Didn't you desolder the transformer on one of these just before to do it? Yes, I did. This one, luckily, is slightly more out of the way. So you see on this transformer here, this is the lead that I usually have to desolder and pull up just to do the chip. But fortunately, this one I was able just to push it just enough out of the way so I can access most of the pins here. And the hot air gets blown into the underside here, and it's just enough to solder all of the pins. So fingers crossed that that did solder nicely, and that's going to work. Okay, cool. So now that we've soldered the 4 drive ICs onto the board, the next thing we need to do is check for gate resistors. So the gate resistors need to all be the correct value. They need to be, in this amplifier, 4.7 ohms. Now I'm going to just mount this camera temporarily up here. Right, this is just going to be a little temporary mount camera. Where are we? Yeah, so we've got some like interesting angles there, so at least I can show you where the gate resistors are on this angle. Looks like a kind of skateboarding video or something, like the camera's attached to the board, so like woo. Anyway, so yes, we're looking for 4.7 ohms on the gates. So if we probe the gate and then where the gate comes from before the resistor, we have 4.7, which is perfect. And we check this one, 4.7. Okay, this one's 54. So this one's dead, and this one's probably dead as well. To get in that. Oh, screw it, I can't use that camera just now. It's too in the way. That's 4.7. That one's not. Okay. That one's 27. Okay, so there's 2 gate resistors here that I need to change. So let's go ahead and change those bad boys. And those ones that we need to change are actually down in here. One of them is this one. Yeah. This one here is one of them. Alex, what do you say was wrong with this one? Blown power supply, as always. The Taramps always blowing the power supply like boof. Power supply blew off. And they seem to blow their power supply for seemingly no reason. Don't understand. So I need to find a spare 4.7 ohm resistor now, and I think I have some of those on the band over here. Yep, there's some spare 4R7s on this bander board, so I'm going to steal some off of here just for the time being, because I've got it with me here. Right, there we go, there's one 4R7. And let's get a second one just here. There we go. I'm going to grab another couple of these actually, because I think I'm going to need a couple more as well. I will take 4 4R7 resistors. How many Soundstream XXX15K is out there in the UK? I've never seen one. So yeah, I usually see a lot of things. I haven't seen one, so it doesn't mean that there's not one, but I haven't seen one. That solder's pretty old. I can't be bothered. I'm going to solder that on manually. I'm going to have to take my camera away because that's right in the way of where I want to solder. See any Ravens? Yep, seen a couple of Ravens. I've repaired a kicker warhorse. Yep, that's right. I have repaired a kicker warhorse. I think it's time to crack open a new solder. I was waiting for this day to come. I always like cracking open a new solder. What's the best way to test the inductor coil on the power supply? You mean the transformer? Seem to be getting the same ohm reading between the legs on each side. Yeah, you will do, Scott, because it's a pretty much dead short. So the only way to test that is with an inductor reader like this, some kind of multi-test unit like this. This reads inductance, so you can use that to read the inductance of the coils, and that's the only way to check if they're alright or not. Your new van is awesome, and sadly the wig suits you. I don't think that's a sad thing. I'm actually making some upgrades to the van before I go to Modified Nationals. So if you are based in the UK and you're coming to Modified Nationals this weekend, I'm going to be running a pair of DDZ15s. Yep, DDZs. The new Z3s, not the new black motors. Can't quite afford those. But someone a good friend of mine is very kindly lending me his pair of silver motor. They're the ones just before the black motor. So they still have the Neo upgrade. The upgrade on the Neo class, but they're not the black ones. But I will be running Z15s in the van, still only on 4.5k at 0.5 ohm. So it should feel like a 7k amp, but yeah, I won't have any more power in it than that. Where's the event held? It's held in Peterborough. The solder that I use is this. Zaga the Bassman, you should come to Modified Nationals, man. It's literally the home. It is literally the home of the UK audio bass scene, UK bass audio scene. Like literally, everyone that is seriously into competing is at Modified Nationals, and you'll see some phenomenal systems, and you'll get some fantastic demos, meet some lovely people. It's really good. Sadly, I think you're too late now to buy tickets. You can try, but I don't know if there's any tickets left now. Check the rest of these gate resistors, make sure that they are all 4.7 ohms. I think these ones all survived. Yeah, I think these ones are all good. So the only thing left now is there was a small resistor up in here. So there's a 4R7 resistor that's also next to the drive IC. There's a missing pad just there where the resistor should be. There should be a 4R7 in there as well. So I'm going to drop a 4R7 in there. Come on, melt, you little bastard. Melt for me. Melt like butter. Oh, there we go. That's one end of it melted. Just gotta push it through. Get the other side connected. There we go. There it is, baby. Oh yeah. Skills. Okay. Right, so that's that 4R7 done. That's that one done. That one done. Alright. Cool. So now the drivers are replaced. We do another power up. This is the second time we're going to power this up, and we're going to make sure that those pulses that we saw that were previously on the gate driver pads are now at the actual gates of the MOSFET pads. Let us see. Fingers crossed this is going to be good. Did you ever get a demo from Greg Fagan? No, I didn't get a demo of his old Touran, but I'm going to be getting a demo of his new one. Of his new van. I think it's a Ford. Okay, so let's go ahead and power this up and see whether we get good drive waves on the gates now of the actual pads themselves. Okay, so that looks good. We've got a 4.8 volt RMS wave there. Yep, 4.8. 4.8. 4.8, that's good on this side. And let's check the other side. 4.8, yep. 4.8. Cool, okay, this all looks good. So I think we're now ready to go ahead and fit some new FETs in this. And then it should be up and running. Cool. I caught a stream. Wow, says Robert. Yeah, you caught a stream, man. Everybody that's watching, you caught a stream. Congratulations, my man. Right, now, I don't have any FETs for this, so what I'm going to have to do is I'm going to have to steal the FETs from this Banda 7K, because this uses RFB 3077s, which are actually better than the FETs that Taramps uses by factory in the HD10K. So you'll have to bear with me, because I'm going to have to go ahead and desolder all of these from the Banda so I can go ahead and put them in the Taramps. Hopefully a quiet night so I can watch the stream, says Crazy Logic. Did you get the parts for the JL Audio? Yeah, I've ordered them, but they haven't arrived yet. So the parts for the JL Audio, I needed the driver ICs. Sorry, the drive transistors, the little small SOT89 parts. They haven't arrived yet. But as soon as they arrive, I shall be continuing the repair on live. Because the JL Audio has still got a lot of work to do. We've still got to obviously finish the power supply repair, which we're waiting for the parts. And then we've got to do the output section repair. And the output section repair is the most interesting part of the JL Audio repair. So, yeah. Oh, I love a new solder block. I love a new reel of solder. It's like, feels really nice and heavy. It's like, yes, I can do lots of work with you. Always love watching these live repairs lately, says Jay. Oh, cheers. I'm glad that it's entertaining for you. I'm glad that it's somewhat entertaining and that it's not just a boring ass. I mean, I don't know, like, for me, I can't imagine how the hell this stuff is entertaining for you guys, because it's just, I don't know, like, for example, this next section of the live stream, I'm just going to go ahead and remove 18 power supply FETs, and then put them in the other board. And that's probably going to be a good half an hour's worth of live stream. So if you have some things to do this evening rather than watch my live stream, and you want to just jump on when we actually find out if it works or not, then maybe go away and make a cup of tea for half an hour or something, because other than me chatting rubbish, that's probably all that's going to be happening for the next half hour. Because these FETs are quite stubborn to remove. So I might be here for about half an hour removing these and resoldering them into the new board. I love watching these too. I like to put it on in the background when I'm working on my own gear. That's fair enough, actually. Yeah, it's like some people put the radio on in the background. Some people have the television on in the background with something that they're not watching. So I suppose if you've got something that you're interested in, if you're interested in amplifier repair, having somebody repair an amplifier in the background whilst you're working, and you can pick up on tips and stuff here and there as you watch it, is pretty useful. This cold needs to go away finally. Crazy Logic says, yeah, I have to order them for my JL. Found a thread where Perry said to use 2SD1898 and 1260 as a direct replacement. Okay, cool. Actually, that might be what I ordered. I found some replacements myself on RS Components, and I ordered them. And it would be very funny if it just happens to be the ones that Perry recommended. Oh man, the FETs on these banders are very stubborn. See, the bander is a really good quality amplifier board because there's a lot of thermal mass, there's lots of PCB thickness, and that's a good thing because it means that a lot of current can pass. It's a bad thing when it comes to desoldering because it means that it takes forever and there's a lot of heat on the board. But it's a good thing in terms of the amplifier's actual operation. Just a bit of a nightmare when it comes to desoldering the FETs, because you're like, fucking hell, it's taking ages. Hi Coogan, how's it going, buddy? Do you only stream large amp repair, or do you work on smaller stuff? Yeah, the live stream this evening actually started off with a very small little JBL GTO 75.2. So a tiny little 2-channel. Unfortunately, I had some problems with my microphone and also my internet, which meant that that you guys missed out on that repair, sadly. But yeah, I do live stream smaller stuff as well, not just the big stuff. Size doesn't matter, it's what you do with it, as they say. I usually browse classifieds on forums looking for gear I can't afford yet, but with your stream in the background it makes it less painful. That's fair enough. You see, right, this is how I've worked my way up in car audio, okay, in terms of being able to afford things. So basically, I would only ever buy something, yeah, I'd only ever put my money onto something if I knew for certain that I could sell that thing for the same or more as what I paid for it. And that's pretty much how I go about my life in general all the time anyway. I don't like putting my money onto things, I don't like buying things if I can't get that money back at some point later down the line. So pretty much everything I buy is almost like an investment. So, you know, the van, for example, I bought the van. You saw my latest video with the Mercedes Vito. The only reason that I bought that was because it was offered to me at such a ridiculously cheap price that I knew that I could buy it, I could exchange my precious pennies for the van, but I haven't lost that money because that money is now in a van. But the van is worth a lot more than what I paid for it. So actually, I've just made a good investment and I can get that money back plus more when the time comes to sell it, or I can sell some equipment from inside it and make some money back, you know. So I don't feel like I've actually spent any money. I feel like I've just swapped some money temporarily for a nice object, and then I can get that money back when I like to get it back. So this is why I really will never buy anything brand new if I can help it, because buying things brand new, you are saying goodbye to your money forever. You're never going to get that money back on that brand new item because it's immediately devalued. So although buying brand new is very nice sometimes, because you know no one else has played with it, you know that it's yours, you know what is history, it's fresh, it is a nice thing. And don't get me wrong, I do buy some things brand new. Like, you know, you can't go live buying everything second hand and making money on it. So I bought a projector, a home cinema projector, for example. Now, the reason I bought that brand new was because projectors, they deteriorate over time, especially the bulbs. And the bulbs are pretty expensive. And what I didn't want to do is I didn't want to buy a used one and then have the bulb die on me and have to pay out and pretty much be spending the same amount on a brand new one anyway. So I made sure that I bought a projector that was a very good price. I made sure it was on sale and that I got it at a really good price anyway. So yeah, I will buy some things brand new. But generally, with car audio and stuff like that, so I started out, so my car audio stuff pretty much started out with a pair of Pioneer. I bought a pair of Pioneer TSW121 SPLs, which are the 600 watt RMS things. I bought those for like 20 quid each. That's like 25, 30 bucks each. Nothing. You could probably pick them up for even less. Now, I could sell those for the same or more. But I didn't. I kept them and I used them, and one of them blew, and I'm still using one of them to this day. So my original purchase of my original car audio sub is still actually upstairs in my room, and I could sell that for now £45. I think I could get £45 or £50 for that. So I could actually double my money on that. Even all these years later, I still haven't lost that money. Then I bought a pair of Pioneer SPL 3004s, which are the 1000 watt RMS versions. I used those for a long time, as you know in my videos. I've got lots of videos of my Pioneers, and I sold those for a profit. So then I had more money to spend on car audio. So I started off with like maybe, I don't know, £60. I think I spent £40 on those Pioneers. I used them and I sold them for £75 each. So I then had £135. So I've made money. So then I had £135 to spend on car audio. I think then I bought the Xeon 15s. They cost more than £135, but I put a bit extra money into them. I bought the Xeon Audio System Xeon 15s, and they were fantastic. I used those, and I sold those again for a profit. And so then I had more money to spend on car audio. And then I bought some amplifiers. I bought the Impulse subs, which I bought for £20, and I sold them for like 80 the pair or something. So I then had more money for car audio. So yeah, basically anything that I buy, I make sure that I can sell it for the same or more than what I paid for, and that way you can keep buying nicer and nicer equipment without it actually costing you anything, because all the money that you're spending has come from buying and selling stuff that you used anyway. So that's kind of how I see it. That's how I've built up the ability to buy nice equipment, is just from going from the bottom up, buying used equipment and selling it for more, and just going there. Can you upgrade the FETs to get more power? Josh, no. Well, yes. Well, no. Right, so the thing you need to understand is to get more power from an amplifier, you need to increase the rail voltage on the output section, okay? That's the only real way you get more power at 1 ohm. So let's say that you're stuck at 1 ohm, you've got 2 dual 4 subs, so you've got 1 ohm. That's it. You can't do anything else, you're 1 ohm. So your amplifier does 2000 watts at 1 ohm, okay? How do you get it to do more power? If you change the FETs might be capable of doing more power, but they're not being told to do more power because you're still at 1 ohm and the rail voltage in the amp is still the same. So the voltage isn't any higher and the current draw isn't any higher because the ohms is still the same. So having bigger FETs in there is a bit like putting a bigger engine in a car but still driving at the same speed. It's there, it's available, the extra power is available to you, but you're not using it. So in order to get more power from an amplifier, you actually have to increase the rail voltage. Now there's a couple of ways that you can increase the rail voltage. The most simple way to increase the rail voltage is just to increase the input voltage into the amplifier. So obviously normally you run it at 14 volts, but to increase the rail voltage, you might want to run it at 16 volts or 18 volts. That's why people run their amplifiers, run their car audio systems at 16 volt charge system or 18 volt charge system, because it increases the rail voltage inside the amplifier, which then in turn makes it do more power. if you don't want to run your car at a higher voltage, 16 or 18 volts, then the only other way to increase the rail voltage inside the amplifier is to rewind the flipping transformers, which is not a simple task, and it's not something that is cost effective or time effective. It's just a massive waste of time, and you risk blowing up other parts of the amplifier that are not expecting such a high rail voltage. Yeah, it's not feasible. It's completely pointless. So if you want more power from your car audio setup, there's no point in trying to make your amplifier do more power. Simply sell your amplifier and buy a more powerful amplifier. That is how you get more power. You buy a bigger amplifier. That's the only way. Now, if your impedance, if your ohm load wasn't stuck at 1 ohm, let's say that you had the ability to wire down to 0.5 or 0.35, but your amplifier didn't like it. Your amplifier wasn't very happy at 0.5 or 0.35. Now that is when you can make some changes to the amplifier that make it do more power. If you're running your amplifier at 0.5 or 0.35, then the thing that's limiting the amplifier's power is not the voltage but the current handling. So by fitting better quality FETs, higher current FETs, the FETs will do more, they can sink more power, they can supply more current before they blow. So that is something good you can do. However, if you put bigger FETs in, then whatever's providing those FETs with power also needs to be upgraded. So you not only need to replace the FETs with higher current FETs, you need to thicken the traces on the board, you need to improve the rectifiers, you need to upgrade those, you need to upgrade the power supply FETs, you possibly need to upgrade put bigger transformers. So basically you have to start from scratch again, upgrading every single other flipping component in the amplifier so that it actually does more power. So at the end of the day, really the ideal thing is sell the amplifier, buy a more powerful amplifier in the first place. That's the best way. Yo, Adam Francis, good evening, sir. Adam Francis has life in his system now, I believe. Have you had a listen yet, Adam? Have you had it playing at all? Does it sound nice and loud and windy? And Adam, remember that if you're trying to tune it low, your no wall that you had last year will definitely play lower than your wall will this year. No walls play lower by default. So if you're thinking, it doesn't drop quite as low as my no wall did, then that's just how walls and no walls work, man. Walls are brutal. Walls get loud as fuck, but they don't drop quite the same as a no wall does. She burps on battery power, mate. Oh, fucking hell. How about, what's going on with the alternator? Have you sorted out your problems yet? Finally! Oh no, we've got one left. I was going to say all the power supply FETs are now off the bander, so I can put those in the Taramps. Bye bye bander. Bye! I know, mate, it's tuned to 25, so I'm happy. 40 sounds louder. That's good. 40's good. Nice and musical. Hello to Brian. Is that because less cabin space, thus less cabin gain? Yeah, partly, yeah. The cabin in a walled vehicle has a much higher resonant frequency. And also it's to do with the distance that you're sitting from where the pressure is being created. In a no wall, there's two pressure nulls which are far apart from each other, which allows a low frequency standing wave to build up a lot easier in the cabin. Whereas with a walled vehicle, the cabin is much smaller. So although you get more pressure in the smaller cabin, the lower frequencies don't build as naturally as they would do in a larger cabin. Steve's sending me a pre-wired idiot-proof one for Tuesday. Can you give my channel a shout out? Yo, go check out Subwoofer Guy's channel. See what videos he's got. If they're any good, come back and let me know. Then 2 days break-in. Also, we'll let that amp... Wait. Paul Wisdom says, also, we'll get that amp to you at some point soon, having to nurse the missus at the moment. Oh, that's... Sorry to hear that. Yeah. But no worries. Just whenever you're ready, buddy. No rush. Whenever you're ready. What temperature do you use for hot air gun? Anywhere between 350 and 400 degrees generally. Lower frequencies, longer wavelength. Yes, exactly. Exactly what... Pepper Demon, what's up, Sam? What's going to be the plan for your new van? So if you watched my video, I explained the plans for it at the end of the video. But for Modified Nationals show, so the big car show in the UK that I'm going to this weekend, that I'm going to make lots of nice, sexy videos of, I'm actually going to be running a pair of Digital Designs Z3. So the Z woofers, the big, expensive bad boys. I'm going to be running a pair of those 15s in the van, and I'm still only going to be using 4.5K. The van isn't ready for anything more than 4.5K just yet, but it will be running 4.5K at 0.5, so it will feel more like 7K. Would you consider what would you consider bare minimum equipment to do a beginner learning setup? I have a 500 megahertz, 4-channel scope, ATX computer power supplies, adjustable. Is the ESR MOSFET tester a must-have? Yes, the ESR MOSFET tester is very useful and it's very cheap, so there's no reason not to buy one. Like, if it was expensive, then yeah, I'd say maybe you don't need it, but it's really fucking cheap, so just buy it anyway. You might as well buy it. It doesn't cost much, and it's really, really useful. It allows you to test capacitors, inductors, transistors, transformers, MOSFETs, diodes, and also, yeah, pretty much anything you want to test, it can test. Probably test your urine sample as well. Yeah, now you see, if I was going to be running 13K or 15K in the van on the DDZs, then yes, I would probably kill the metalwork. But I think on 4.5K at 0.5, so like what, 7K, I think the metalwork will be fine. I don't think we're going to kill the van on that much power. But we'll see. We shall see. What do you think about Taramps? I have a 3K, not bad. I have on 212s. Yeah, the smaller Taramps seem to be better than the bigger ones. Taramps generally are pretty shit. They always blow the power supply. Yeah, I wouldn't recommend Taramps at all. No. Bander, yes. As long as you buy a good Bander, yes, very recommended. They have much better circuit designs than the Taramps. What's the issue with that Taramps? It blows the power supply every goddamn time. All Taramps blow the power supply without failure. If you own a Taramps amplifier, and if you run it for any considerable amount of time, you will, without doubt, have a blown power supply at one point in your life. There is a design flaw with these amplifiers. I've yet to find the cause, but whatever it is causes the power supplies to what the fuck? Spontaneously die. I had a proper little fucking brain freeze there. That was weird. Spontan. What about Stetson? Stetson build quality is very bad, so I can't recommend Stetson. The circuit design is pretty much the same as Taramps, but the Stetson build quality is very bad. Like they don't secure anything down properly. It's all just cheap and nasty inside. It's all flexing around. It's going to get vibration damage. No, I don't recommend Stetson either. Pepper Demon says by overheat. No, not by overheat. These things blow their power supplies even when they've been running like very, very low volume and very cold. There's a glitch somewhere. These amplifiers have a glitch somewhere that kills the power supply. Like something goes and it kills the power supply. And I haven't figured out what it is yet, but I will get to the bottom of it, I'm sure. Right, so that's one line of FETs loaded up on the Taramps. Let's do the other side now. What would you use in the 3K range? Does it have to be Brazilian, or can I recommend something Korean? Anything. So obviously we live in different countries, so we have different brands available to each other. So I'm gonna, I'm not gonna give the best advice to you because I don't know what things cost. There might be a really good value for money option you can buy, but I would probably look for something similar to the Ampere Audio. So, something like, I don't know whether Ampere Audio do like a 3.5K or 3.8K, something like that. because the Amplifier Audio is the same boards as my LW audio amplifiers, and they are fucking bulletproof. They are insanely reliable. What do you think about the Pride subwoofers? Well, I mean, I've only seen pictures and videos. I've never seen any in person, so I can't really comment. They look a bit plasticky and a bit like... I tell you what, they look very inefficient and they look very not musical, but they look like fucking powerhouse beasts that will make big numbers when given big power. So yeah, in terms of getting numbers and making lots of noise, yeah, they look pretty good. They don't look very musical, don't look like they're going to sound very nice, and they don't look very efficient either. So it depends what you want. If you want numbers and noise and lows and stuff, then yeah, Pride look pretty badass. If you want daily musical and you don't want to be draining your batteries and you don't want to be kicking out shit tons of power without needing it, then maybe not. Okay, 3 more FETs to go, and then we are ready to see if this Taramps is going to actually work or not. What does an amp need to be reliable? It needs to have the inductors and transformers securely seated down to the PCB. It needs to have a non-stressed Class D drive IC, something that is driving the output MOSFETs and it's not getting hot, it's not under strain or stress. It needs to have long life capacitors that are well within their voltage tolerances. It needs to have output FETs that are well within their voltage limits. It needs to have enough output FETs to well cover down to 0.5 ohms worth of output daily. It needs to have, yeah, like I say, thick PCB traces that aren't going to current limit the amplifier in any way and cause internal voltage drop. Needs to be well-designed PCB that doesn't induce excessive ringing into the drive circuits or into the audio signal. There's many factors that contribute to how reliable an amplifier is. Many factors. And they all work together to create something that works over a long period of time. I have a 10k Taramps also just not ready to upgrade under the hood. Says Brian P. He needs to do that pretty soon, man. Okay, now we just solder the remaining legs, so all the FETs are in. We just solder all the legs down, and then we can fire her up and see what she's saying. What you saying, girl? Do you think these Taramps are amp hogs? I don't know what you mean. Has it happened to you? What do you recommend for music in a stock battery and alternator with Big 3? What do you mean, what do I recommend for music? Oh, sorry, what do you recommend for music? Stock battery and alternator with Big 3. Up to 1,500 watts RMS, depending on the car. Anything more than that and you get excessive voltage drop. So stick to 1.5k. Something efficient, something like a Digital Designs 3500 series or 2500 series. Has it happened to you? For unexplained reasons, the amplifier to create popping sound with weak signal input. No, not that I'm aware of yet. Popping sounds with weak signal input. That sounds to me like the gain, knobs, or the switches are bad. If the amplifier has no other issues, if it's not getting hot, if it's not going into protect. Popping sounds and low outputs sounds like the signal path is interrupted by some bad switches or knobs. What's the deal with this segment display? What do you mean, buddy? Right, okay, finally, all the IRFB 3077 FETs from the Banda are now in the Taramps, and so I'm just going to do one final check before we apply power. The amplifier is going to come on fully now, and the output section is going to start working, so we got some scary high voltages going on over here. I think the rail voltages, they swing to like over 200 volts, which is pretty scary stuff, so we want to make sure that we have a short circuit somewhere. We have a solder bridge somewhere, so it's good that we check this. We've got a solder bridge between battery plus and minus. Okay, I'm going to go hunting for solder bridges now then. Isn't that a segmented display on that PCB? Ah, yes, sorry. Yes, of course. This is the voltmeter that comes on the Taramps. So it's a voltmeter on the front of the board. Where's the solder bridge that's causing that connection there? There is one somewhere. Alright, let's go through every single one with my soldering iron and try and find where it is. Can't see it anywhere with my eyes. Aha! Found it! You little bastard. That was a very hard to see one. Okay, so now I should have got rid of my continuity between positive and negative. Which it has. We're now charging up to infinity because we're charging the power supply capacitors. That's good stuff. Wicked. So, now that we've got no continuity, no more solder bridges, let's go ahead and power her up and see whether it's going to work. I'm going to allow, let's see, how much current shall I allow pass? Let's say 6 amps. Let's allow 6 amps to pass, and let's give her let's give about 10 volts. Stabilize. There we go. If I fucking remove my hand, it destabilizes. There we go. Okay. Yeah, using good flux. See, the problem is the flux that I have is actually goes conductive when it heats up, and I haven't managed to buy any new flux yet. So, but yeah, decent flux would help prevent solder bridges for sure. Absolutely. And Danny repairs on DD-M4Bs. Yes. Let's wait for my... So Danny repairs on any M4Bs. Yes, I have. And the M4Bs are nothing special. They are pretty much just a generic Korean style board that you see in all sorts of other brands of amplifier. So they're nothing special. Sad to say. You know, they're a good amplifier. If I'm perfectly honest, I don't think they're not worth what DD charge for them. They're the same as everything else. Okay, so let's put some power to this, and I'm going to put you on the scope view so you can see the scope. So we can see here that we have, let's go zoom out a little bit. So we can see here that we have our battery voltage weighting on each of the FETs here. We need to just check that we haven't got any DC voltage on any of the gates, which we wouldn't have, because if there was, then these would be drawing current. So, let's see then. We need a good square wave on this bank. Looks like we're going to have a good square wave there. Yep. We need a good pulse on this bank. Yep. A good pulse on this bank. Yep. And a good pulse on this bank. Yeah, looks pretty good. I'm just going to compare the gate drives on this. So I'm going to go down to 2 volts. Okay, yep. So they look mostly similar. Some slight differences between them, but nothing too bad. Okay, let's zoom back out and let's see the rail voltages. So the rail voltages will now be climbing. So the rail voltage is already at 55 volts. So we're going to need that to go higher. We need that to go all the way up to its complete top rail. We're at 90 volts now. $116 volts. $151. Oh, and we have the switching. So that's the Class D switching on the output section. So the power supply should look nice as well. Yeah, power supply looks pretty nice. Let's compare that wave to this wave. Looks the same. This wave looks the same. This wave looks the same. This wave looks the same. Let's compare the drive. So the drive looks like this. Okay, yep, looks nice. Let's compare that to this one. Looks nice. Compare that to this one. Looks nice. Compare that to this one. That looks a bit noisy, but I think it's probably fine. Yeah, okay, cool. The fans are slowing down, it seems, which is weird. But my voltage has dropped to 9.2, so maybe that's why. Alright, cool. Well, it looks like it's pretty stable. So what I'm going to do now is I'm going to go ahead and put the amplifier back in the case, and I'm going to run some endurance tests on it to make sure that it stays working this time and doesn't fucking explode. Nice. Successful repair on this one. So just to recap, on this Taramps amplifier, we had to change. Let me take this camera so I can show you zoomed in. On this amplifier, we had to change the PIC chip, which is this little brain here. This is the brains of the amplifier. We had to change that. We had to change all 4 of... Oh, come on, wait for it. We had to change all 4 of these drive ICs. We've got one there, one there, one there, and one there. We had to change all 4 of those. The power... On the power supply, we had to change all those. We also had to change some gate resistors over here for the power supply FETs. And we obviously also had to change all the power supply FETs themselves. And that got this thing back up and running. Now, just because we turn the amplifier off doesn't mean that it's safe. There is still some very scary high voltage sitting on the output section. You do not want to touch that. As 126 volts DC, you do not want to touch that. So, in order to make this amplifier safe, we need to take a small resistor, like so. Now, this is quite a high value, and I'm going to short this out through the resistor to ground from the rail voltage, which I believe is on this rectifier. So we're going to go to ground on here, and we're going to touch that on there. Like so. And the voltage, you can see, actually if I clip this to the rectifier, you can see the voltage sink down. Where's my clip? Ash the Gamer, what's up, buddy? So yeah, we're going to watch the rail voltage. So the rail voltage is currently 106 volts, and it's not really moving. It's moving very slowly, 106, 105.9, 0.8. Whereas if I start shorting it out through the resistor, we're losing pretty much a volt a second, or greater than a volt a second. So I just got to hold this on here for probably about 30 seconds or a minute. When it gets down to about 50 or 40 volts, then I can short it out through the bigger dummy loads safely. Just quickly asking a question for you guys. How does the image quality, the picture quality of tonight's stream look? Because I'm streaming at a much higher bit rate than usual. So let me know how the stream quality looks compared to normal. Does it look quite nice, or better or worse than usual? Let me know. Okay, so now we're at 49 volts, so I can go ahead and safely short this out through the dummy load rather than through the small resistor. So this will make a nice spark. If you want to see the spark, then you probably want to go to this view. You might see a spark. Is it hidden behind the capacitor? No, it's hidden behind the capacitor. But yeah, there we go. Now we're safe to handle the amplifier, pick it up, move it around, etc. And we're not going to get a shock. Yeah, I've noticed that using this slightly higher bitrate, the quality looks better, but as you guys are saying, sometimes the stream goes offline for like a couple of seconds. So that's a bit annoying, so I'm not sure why that is. Every now and then my OBS just drops out and it sort of goes to 0 kbps for like a couple of seconds and it comes back again. Alright, so next then, now that we've finished with the Taramps, let's have a look at this Ground Zero Titanium High Power Amplifier. So what's going on with this one then? We've still got some protective plastic on here, but it's a little bit scratched up. What's your opinion on B2 Audio? Fucking brilliant. I love B2 Audio. They're a very good brand. Very, very good quality equipment. Nice, nice stuff. You pay for it, but it's really good. Yeah, guys, how many of you guys actually watch in 1080? So, first things first, as always with any brand new amplifier we get on the bench, let's make sure there's no continuity between plus and minus on the power input. Okay, no continuity, that's good. So I'm just going to open her up because I'm curious to see inside anyway. I'm going to see if there's any blown parts in this. Lots of people on 1080p. Okay, cool. Okay, so already this looks like a cheap piece of crap. This is a really cheap, nasty, generic amplifier. So, this looks like a Class D. Is this a 2-channel or is this a mono? This is a mono. Alright. So this is a Ground Zero mono amplifier. Would you do hi-fi equipment? Nah, not now. Not for me. So does it have any shorted output FETs? The output FETs you see will be over here. So we're just checking in between all the legs to see whether any of the output FETs are shorted. Okay, nope. All the output FETs are not shorted. Power supply FETs are not shorted. Okay, so I wonder what is wrong with this amplifier then. So we have no shorted FETs, no shorted power supply, no shorted output section, so we are more than safe to go ahead and plug this into the power and see why the fuck this is in my workshop. Yeah, I always forget to keep changing the current amp. I don't know how much power this is, so I'm just going to call it GZ Mono question mark. I'd say this is probably going to do about a K. I should really check my phone. I think it's gone off about 1 million times. Okay, and let's put the, so that's the power in. Let's put the ground in. And the remote. So who thinks, is this amplifier going to work just fine? Is it going to work straight away? Or is there going to be something wrong with it that's fucking a headache? So, this amplifier... what the fuck? So what do you guys think? This amplifier, there's no shorted power supply FETs, no shorted output FETs. So, is this going to work straight away and there's going to be no problem with it? Or is there going to be a really headache issue that's going to take me a long time to find and a long time to sort out? What do you reckon? Okay, so we've got one guest says intermittent problem, one guest says pain in the arse. Hope things going well for ya, says Basehead. Basehead hopes it's going to be alright. At least Ground Zero have secured the inductors and transformers down properly though. That's one thing that's good. Okay. So let's power up then and see what is actually happening here. Okay, so power supply comes to life straight away. We have nice square waves there. The amplifier has a green light, which means that it's working and not in protection. We have output section, class D switching, so the output section is working well. Okay, so it doesn't appear to be any problem just yet. Okay, so the next thing to do is to see whether this thing does any audio. So we've got 32 Hertz going on at the moment, and let's just turn the gain down a little bit. Put the line in, and let's check for audio. Do we have any audio? Speaker plus, speaker plus. Let's zoom in a bit. On 2 milliseconds. Turn that up a bit. Turn the gain up. Yeah. So we've got audio. And it clips off at about 34 volts, so yeah, I think this thing is going to do about 1,000 watts or so. Okay, well, fucking hell, it works fine. All I need to do now is a bench test, and yeah, nothing wrong with it. Everything's seated down properly, it makes audio, so I'll run some tests on it, but it doesn't appear to be any problem with this bad boy whatsoever. So that's, like, yeah, that's nice. Okay, move on to the next one then. But I will bench test this and endurance test it in my own time, but you know, that's boring for you guys to watch, so I'm not going to do that just now. I'll do that later. Okay, next! Alright, what's in here then, I wonder? Have a box of goodies. Let's see what's in here. Yeah, the JL audio parts haven't arrived yet, but as soon as they do, I'll do another live stream of the JL audio. But the parts are still in the post for that one. It's a Sunday today, so I imagine I'll probably get the parts for the JL audio will come tomorrow. Ooh, what's this? I think I know what this is. I think this is a really, really old school Fusion. Yes, it is. This says Fusion Jonah Lomu. I should probably know what that is. This is some pretty old school Fusion stuff. So I'm going to change this to this text here to old school Fusion. So let's see what's the matter with this one then. Whoa, mamma mia! Okay. So this is a very, very old school design Class D. And it's the kind of old school Class D designs that are a fucking headache to repair. Oh look, it's my first amplifier that uses these F16 and B whatever it is. So if we look on here, no, I'm going to use the zoom in key. I'm going to use this. So this is the first amplifier that I've had come into the workshop that uses these chips. Wait for it to focus. Do a repair in German. I have no idea how to speak German, sorry. F16 and B52 chips. So this is a common old school type of Class D amplifier. Yeah, Fusion was in the 90s. That's old school. Yeah, there are some really old school Fusion stuff. So, I'm going to see what's the matter with this thing then. So, output section. Is there any shorts on the output section? Let's see. It looks very clean inside here. Okay, phew! Doesn't seem to be any blown output FETs. That's a relief. No blown power supply FETs either. Alright, so let's power it up and see what the problem is then. I reckon it could be just really old, dusty potentiometers and stuff like that. Seeing as this is quite an old amplifier. Okay, so power is in. Flick the switch. She's on, up and running. And let's now hit the remote and see whether the power supply comes to life in this. So we need to turn the scope up a little bit, turn it back to zoom it in a little bit to 2 US and reject low frequency and power. And we have a square wave, so the amplifier has turned on. It's not in protection. We have a green light and no red light, so that's good. And we have Class D switching. Right. Okay. So the actual amplifier side of this thing appears to be working fine. But does it make any audio? Let's have a look. Okay, speaker output, let's have a look. Yeah, appears to be making audio. Someone said before they should tap with a screwdriver. Yeah, it seems fine. Let's crank the voltage up to 14 volts and see if that's any issue. That seems good as well. Ah, okay. So I'm going to consult the customer and just ask him what the issue was with this one. Yeah, seems to be nice to me. Really nice condition. Looks fucking brand new inside here. Really well kept. Let's check that the switches aren't noisy, actually. That's one thing we can do. We can make sure that all the switches and knobs aren't noisy. So let's go ahead and start turning some of these level. Note that looks nice and clean. The subsonic, that looks pretty clean. Low pass filter, yeah, that looks good. Q, that's for the low pass. That's not doing anything weird. Phase shift knob. Yeah, seems good as well. Yeah, all the switches look good. Weird. Okay, cool. So I'm going to ask him what the issue is with that one then as well, and yeah, weird. I'm actually just going to really quickly look up his conversation on my phone now, because I'm a little bit confused. Okay, let's check in here. So not in this one. Maybe it's on my NSV page. Bevis page? Okay. I know I've had a conversation with this guy, but I can't seem to find the conversation anywhere. So I found him on Facebook, so I'm sending him a message, but I haven't. It doesn't seem that I've had a chat with him before on that Facebook page, on that Facebook Messenger. Very strange. So we'll just wait for him to reply, and he can tell me what the issue was that he found with this, because I can't find any issue with it. Did you ever get those crown amps working? Oh, from years ago. Yeah, of course. I sent them for repair. I mean, that was like back before I was ever touching any electronics. I sent them for repair, and yes, I got them fixed. I still have two of them. I sold one of them, but I still have two that work beautifully. They work really, really well. Okay, so that's two nice and easy amplifiers that haven't needed any repair. Let's go to the next one. Now this is old school. Is Bevis in Australia? Hell no, 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 no. UK, my friend. This is a Hyphonics Zeus. Old school. 2-channel. Very power. So let's see what's going on inside this one and if there's a problem in here. Now the back of this one looks like it slides off when you release one of the side panels, so let's do that. And it says on the front, Hyphonics made in the USA. So yes, these were made in the United States. Right then, so how does this back thing come off? It looks like it just slides out when you release one of the side panels, but clearly it's not as easy as it sounds. And give it a small tap on this side. Okay, no, it's not helping. These fucking screws get stuck on the end of my screwdriver. Right, okay, well this back plate should just slide out now. It is slowly coming. I don't want to damage the. I don't want to hammer too hard and damage the end. So I'm just going to put some tester tape over the end of my hammer. It's coming slowly, very slowly. Am I really gonna have to sit there and do that? The fucking. Ah. Thing is, I don't want to hammer this too hard because I don't want to damage the back plate. It's very loud on the ears. Ugh, that's really loud on the ears. Maybe I can get that out with some weight and some leverage or something. Maybe I can put the hammer on the floor and then push down on the handle with the back plate. Now there we go. There we go, that was easier. Okay. So, wow, what a beauty. She looks pretty much brand new inside. And yeah, that's pretty fucking nice. Really, well, I was going to say nicely seated transformer. It could be seated better. Yeah, that could snap over time, actually. So yeah, this is a class AB. So we've got no switching, no inductor. So, let's just first of all check that there's no shorted output transistors. Nope, seems okay. Power supply isn't shorted because if it was, then we'd have a horrific smoke. So I'm going to go ahead and put some power and just see what this thing is doing. there is what's happening. If you've just joined the stream, we're having a look at this old school Hyphonics. There doesn't appear to be any immediate issue with it just yet. I'm just trying to find out what the problem is. And I need to try and find out which is the remote. Ah, they're labelled on here. That's good. Okay, so let's see. Does it come on and does it make audio? That transformer looks non-original. I don't know. The solder connections look pretty original. Trying to find my mini screwdriver to screw down this remote cable. I always seem to fucking lose my mini screwdriver. So annoying. Put it down somewhere. It's always the thing that goes bloody missing. Ah, very nice. Okay, so we have a regulated power supply. That's fucking cool. Yeah, so it doesn't regulate down. If we put 9.3 volts into the amplifier, it doesn't regulate like that. You can see there, that's what the power supply wave looks like. And the power supply output wave looks like this as a result. Nice big square wave. However, if we increase the voltage, let's show you this. If I increase the voltage on the power supply, you can see there that it changes in shape once the voltage goes past a certain point. And it's now pretty much a sine wave on the power supply. Really, really cool. Lovely design. Very efficient. Right, so, okay. It looks like we have operation. It looks like we have our rails. So this is a 2-channel amplifier. So let's see whether this outputs actual audio or not. Okay, cool. So yeah, we have some output there. The gain was set quite high, so let's turn that down a bit. Yeah, so the gain knob seems pretty smooth. Seems to do the nice sine wave. The weird noise you can hear there is the power supply changing in duty cycle as we turn the gain up. See that? And that's my bench power supply that's making those noises, because it's changing how it's working very quickly in sync with the actual amplifier. So yeah, this amp seems to work fine as well, but I will do further endurance testing and whatnot on this one a bit later on. So this is the third amplifier that doesn't need any immediate work or any immediate obvious blown parts or anything like that. John Brass, the only beef I have with this guy is that he handles the FET leads by his hands. Just a little bit of charge from your hands can cause the gate to get destroyed. I don't know, man. No, not with these FETs. I've been doing this. I've been doing constant amp repair every single day for over a year and a half now, which isn't a massively long time. People do this for their lifetime. But I've handled all sorts of FETs from all sorts of everywhere, from all sorts of different types of FET, from high voltage, low current, low voltage, high current, low gate charge, high gate charge, low input capacitance, high input capacitance, and no matter what, I have never ever had an experience where a FET has been dead when I fitted it because I handled it with my hands like this. Like, if I had excessive static built up on my body and I touched the gate and the drain was grounded somewhere else, then yeah, I understand. I would understand that. But no, like, yes, if the MOSFET is inside the amplifier circuit and there is voltage on the source, yeah, and I touch the gate, then yes, the static from my body could be enough to turn the FET on and destroy the FET, because it's then on constantly and it's then just dumped the power to a short. But out of circuit like this, no, like even Gordon Taylor, who works at the Amp Doctor UK, who's been repairing amplifiers for something like 30 years or more, and he designed the Genesis amplifier range, and he works on he helps design the amplifiers for DLS and all sorts of other brands. And he works the same as I do. Pick up a FET with your fingers, no static discharge bullshit, none of that. Put it in the amp, it's fine. I have to wholeheartedly disagree with that statement. Sorry, buddy. Okay, cool. Let's read a little bit of live chat, and then I think I'm gonna take an early night this evening, because it's midnight here in the UK, and I have not been too well over the last few days, so I want to make sure I don't get too many late nights. So I'm gonna call it a night for the repairs tonight. It seems to be going pretty weirdly, like none of the amplifiers I'm choosing seem to have anything wrong with them. Obviously I'm going to do some endurance testing and bench testing and stress testing them over the course of the next couple of days to make sure that they're all good and they do clean audio and they don't trip into protection or anything like that, but that's too long to do on a live stream and pretty boring, so I'm not going to do that live. Tech will have a minimum of anti-static wrist strap when working on the board. Not from what I've seen, honestly. Like in the olden days maybe, but like no modern techs I see ever use anti-static wrist straps. In fact, if I used a wristband that was grounding me, that would make my work 10 times more dangerous, because at the moment I can touch 150 volts DC on the amplifier's rails and not feel a thing because I'm not grounded. So I can accidentally lean on it and it's fine, or I can accidentally brush my hand against it and I don't get a shock. I can feel the heat on the back of the MOSFETs and it's fine. If I was grounded and I touched 150 volts DC on the amplifier rail, then that would be very painful and very dangerous. So I don't think it's a good idea. Like I say, I have never ever heard of any instance from any technician that I've ever spoken to where static on their body damaged a component on an amplifier whilst they're working on it. And the same goes for building computers. Computers are even more sensitive to that, and I've never heard of anyone damaging any computer component while they were building it because of static. I've never heard of it. I've built hundreds of my own computers on the fucking carpet, whatever, with no static safety measures, and I've never had any problems. So yeah, I think it's one of those things that's like just too pernickety. It's like, you know, there's like a 1 in 10,000 chance that this might happen. No, I think it's too silly. Okay, I am tired and cranky, so I am going to get an early night tonight. Thank you very much, you guys, for joining in the stream. Hope it was interesting to you. I repaired the JBL 75.2, repaired the Taramps 10K, and the other 3 amplifiers that we looked at this evening didn't appear to need any work doing to them, following on a bench test and endurance test. So yeah, pretty nice evening. What's the biggest that you repaired? Probably Kicker Warhorse. The Kicker Warhorse is the biggest and most complicated amplifier that I've ever repaired. Apart from that, it's probably like the biggest power is a Taramps 15K, but the biggest size is probably Ground Zero 10K HC. Haha. Jesse is here and I had no idea, as always. Thank you, Jesse. Yeah, so I hope the stream was good. Tonight's stream was the first stream using my new broadband, so I'm not tethering on my phone anymore. So yeah, I'm using my broadband, and as a result, I'm able to stream at a much higher bitrate, so we're up at 10,000 kilobytes per second, and my computer seems to be doing that very comfortably. Let's see, what's my CPU usage? Because if it's not that high, I could probably go even higher. CPU usage is about 65%, so I could probably even go a little bit higher with the bitrate. I'm getting random dropouts here and there. I'm getting the odd random dropout on OBS, but it doesn't seem to last very long. So I think we're good. And the home broadband seems to be pretty nice and fast. So yeah, I'll continue using that. What are the plans for your van? Like straight away, I'm going to go to Modified Nationals and I'm going to install a pair of Digital Designs Z315s. So the Z subwoofers, or the Z, whatever you call it in your country. You know, the really fucking expensive ones with the neo magnets. So yeah, 2 Digital Designs Z15s with carbon cone, and that's going to be run on the equivalent of 7K, which is not very much power for the Zs, but that's all that the van can take at the moment. So yeah, I hope you guys have a good afternoon and a good evening, and I'll catch you in the next stream. Bye!